Precast concrete blocks for reinforced soil structures have been widely used globally since the 70s. These are flexible structures and are amenable to differential settlements without show of distress, unlike rigid structures. A reinforced soil structure constructed of soil, polymeric geogrids, and concrete blocks is less expensive and faster to construct and is obviously preferred. After ground improvements, wall construction begins with excavating the foundation, typically 1 meter deep and wide enough for the reinforced zone. A PCC leveling pad of lean concrete is now poured with perfect alignment across the entire length of the wall. The first layer of blocks are laid and carefully aligned on the PCC pad. Now, let us look at the blocks in greater detail. The concrete blocks are uniquely shaped to provide both stability and economy. Significant benefits include cost economy, as the blocks do not require any steel. The hollows in adjacent blocks are filled with gravel, which form stone columns. This contributes to the stability of the fascia. The key at the bottom of the block fits into the cavity of the lower block and firmly anchors the geogrid. The position also ensures a backward batter. As all blocks are identical, casting can commence prior to design approvals. This reduces dependencies, resulting in speedier execution. After the first layer of blocks, the reinforced soil zone is now backfilled with non-plastic engineered soil and compacted with a vibratory compactor. The first layer of geogrid is placed side by side without overlaps, covering 100% of the reinforced soil zone for a safe and robust design. The geogrid is pulled taut and positioned in place with wooden stakes. The next layer of blocks is now laid. The key, that is an important part of the block, connects the block to the grid, increasing the frictional resistance for a better pull-out value. This is one of the unique design features of the block system. The entire process is repeated, layer by layer, with primary geogrids placed every 3 layers. Based on stability considerations, short secondary grids may also be placed in between layers. When the wall reaches ground level, the filter media is placed behind the blocks. This acts as a drainage zone and relieves the structure of pore water pressure. It is self-compacting and does not require heavy compaction equipment. Thereafter, the retained soil zone is backfilled as per specifications. RCC coping beam is cast along the top row of the blocks to smoothen the steps and align with the carriageway. Now the carriageway is laid. Finally, the crash barriers are placed into position, the pavement is laid, and the medians are constructed. The carriageway is now complete. Summarizing, the main benefits of the concrete block with geogrid system for reinforcing soil structure are as follows. Economy, as it only requires dry cast and does not require any steel. Speed, as it has lower coordination requirements, hence fewer delays. Also, it requires fewer types of input materials, one type of block, and the geogrid, hence fewer outages. And as it is a simple installation, hence it is an extremely fast construction. Finally, it results in a robust system, as stone columns are formed by gravelin cavities and the presence of secondary geogrids. This provides a perfect phase stability. With 100% grid coverage, it provides a robust design.